Now we move to question number 9. In this question, a set of two different reactions is given to us. In the first reaction, the compound is treated with methanol in an acidic medium, while in the second reaction, a different compound is treated with methoxidine in basic medium. We need to predict the products that will be formed in each of these reactions. So let us proceed with the solutions.
As we have learned in basic, first of all, these compounds are called as epoxy compounds. Now, and first we are adding acidic CH3OH in acidic medium to this epoxy compound. Then we know that oxygen is electron rich, so it will attack H+, which is electron deficient, forming a compound like this and having a carbocation on it.
Yeah.
Now we know that here the carbocation is more stable compared to oxygen, because oxygen never is more electronegative and it don't like and positive charge on it. Therefore, it will rearrange. The carbocation will shift over here, and the compound will be like this. Now, CH3O minus, which is there in the solution, will attack here.
Okay.
And it will result in this will result into ring opening and hence formation of this product and alcohol over it.
Okay.
Now let us see what will happen in the second reaction. In the second, Y, which is more Y, here case CH3O minus or any nucleophile, it is more electron rich.
Right.
And so it will, now this will attack on this group. Now it has two sides, 1 and 2 attack.
Okay.
2 attack. But here, as we know, there is more inductive effect.
Yeah, correct.
Therefore, has high inductive effect compared to this.
Okay.
We are having CH3 only.
Yeah.
And here there is an R which is greater than CH3.
Correct.
If you assume it true, then therefore we know that the electron density over this carbon will be more. That C2 electron density will be more than C1.
Okay, correct.
And compound which is having a high electron density is going to attack.
Yeah,
Therefore,
absolutely.
it will attack on C1.
Okay. So this is different from the case which was observed in the previous part.
Yeah, because that was carried out in the acidic medium and the same compound is reacted in a basic medium, so the product form will change now.
Yeah.
Therefore, and even the mechanism also. So CH3O minus will try to make a bond over here. Similarly, the O will try to break a bond from here, and here we are having R and CH3, and finally we will be getting OCH3, here CH3, CH3, and over here O minus, R, and a CH3. And the final on adding H plus, the answer will be C, OCH3, CH3, CH3, and COH, CH3, and R. So this is how the two reactions will end.
So fine, we have explained you the process, the reaction process involving epoxy compounds. So the first compound reacted in the acidic medium and the second reacted in a basic medium. We clearly outlined the entire procedure and we obtained the final results.
So now let us start with the 10th question and see how to solve it. The first point, you can see the question is very big. So for solving this, I will give you a method how to approach this kind of problems. The first thing given are, we have two isomers G and H. And the compound is given, which has a formula of C10H12O. C10H12O. The two isomers, which are G and H, has this formula. So in C10H12O or any compound like this, first we will find degree of unsaturation. How much is the unsaturation? We know that in this case the unsaturation is 5. Therefore, the compound has a degree of unsaturation equal to 5. Now, let us proceed further. These are isolated from the oil of bay leaf, okay, and then they are insoluble in aqueous NaOH. That is, they are non-acidic, because if they might react with aqueous NaOH, then they are acidic. And then they decolorize this bromine in carbon tetrachloride and KMnO4 with H+, which means an alkene or alkyne is present. Now we know that the degree of unsaturation is 5. So let us assume a case and let us first see what's more for us in the question. Now in each is vigorously oxidized to para-anisinic acid. So you can see a benzene ring is there. Therefore, we know that the degree of unsaturation for benzene is 4. Therefore, and it has one alkene. So let us see. And on oxidation, it forms para-anisinic acid, which is this. And it's also given in the question that ozonolysis of G and H give the same product, and we know whenever we get same product in ozonolysis, then it has to be isomer, or the both should be an isomer. The both can be either cis or trans. Therefore, let us see what can be the compounds B, as they are forming para-anisinic acid. They should be P O M E, because an oxygen is there, and then we get C6H5 over here, and we have to accommodate both 3 carbon as we have accommodated 2. So for that, 1C. Now we know that it's giving us para-anisinic acid. So a double bond must be present over here. That's why it's on ozonolysis gives a para-anisinic product. Now as 2 G and H were there, therefore they should be isomers of each other. So we need to find a compound which is isomer, now which forms cis and trans with this double bond. Now we know that we have already used 6 plus 3 carbon, it is 9 carbon over here. So 1 carbon is left. Therefore, let me write 1 carbon over here, CH3. And I am having 1 H, which will come over here, and 1 H over here. And thus, on ozonolysis will give me para-anisinic acid, and this can be either G if I consider it to be a trans, and it can be cis, and it can be considered as H, or as nothing is given about G and H based upon their properties, which one is cis or which one is trans. So we can assume this compound to be either G or H, and similarly the trans one can be also G or H. And one question might also arise in your mind, that why the CH3 was not attached here. Because if CH3 would have been attached over here, then it would have formed a ketone, and hence we have to attach CH3 over here. Now the second part of the question, we need to give the structure of third isomer that is also oxidized to para-inosinic acid, and that gives the same product on hydrogenation as does A, G and H. Therefore, the compound must be para-methoxy compound I must be para-methoxy C6H4 CH double bond CH2 CH double bond CH2, which also gives anisinic acid on oxidation and is reduced to para-MEO C6H4 CH2 CH2 CH3 as G and H are, and a chemical reaction which can distinguish between it from G and H is reductive ozonolysis. Because once you do reductive ozonolysis, then G and H gives CH3CHO, which gives a positive test with NaOI, whereas I get reduced to CH2 double bond O, which gives a negative test with NaOI. So this is how you need to approach a question and solve it. Let us proceed with the question number 11 and let's see how to solve it. Compound X C5H8O does not react appreciably with Lucas reagent, and we know Lucas reagent is Cl2 with HCl at room temperature, but it gives a PPT with ammonical silver nitrate, and with excess of MEMGBr it forms 0.42 gram of X. It gives 224 ml CH4 at STP, and treatment of X with H2 in presence of platinum catalyst followed by boiling with excess of HI gives us N-pentane. We need to find the structure for X. So let us see. The first thing, X, which is C5H8O, does not react with Lucas reagent, and but gives precipitate with ammonical silver nitrate. Therefore, it has to be a terminal alkyne linkage as well as a primary alcohol group. Terminal alkyne linkage as well as primary alcohol group. Now the second thing is X on hydrogenation and then reacting with HI gives us pentane on hydrogenation. Therefore, it is a straight change compound as we are getting pentane. Now the third point comes, keeping in the view of above facts, that is X may be a terminal alkyne and it has to be a straight change. Therefore, we get X as pentene, pent 4 in 1-ol, and when it's reacted with methyl magnesium bromide, it gives CH4. That means it has two acid, and here you can see it has two acidic hydrogen or two active hydrogen, and thus 1 mole of X will give 2 mole of CH4. Therefore, 84 gram of X gives 2 into 22.4 liter of CH4. Therefore, 0.42 gram will give what? Let question mark be Y. Therefore, Y by calculating comes out to be 224 ml of CH4. So, let us start with the last question of our topic, question number 12, and let us see how to approach it. So, first of all, let us see what is there in question. A compound C9H13O3N shows optical isomerism when 1,2-dihydroxybenzene is treated with chloroethanoyl chloride in the presence of POCl3. Compound B is obtained. So first of all, when 1,2-dihydroxybenzene is treated with chloroethanol present in POCl3, we get B. So we know both the reagents. So let us first try to make the compound B. This is 1,2-dihydroxybenzene. Hydroxybenzene, which reacts with chloroethanoyl chloride, Cl, CH2, C double bond O, Cl, in presence of POCl3. So it will follow the basic alkylation or acylation. Let us see what all products can be formed from it. First of all, POCl3 is there, and we know we are having 2 chlorine. So either first, let me name it 1, let me name it 2. Either a Cl will be taken from 1 or Cl from 2. If Cl from 1 is taken, then a carbocation will form on an alkyl group and a ring alkylation will take place, and it will form this. If acylation take place, that is Cl, second Cl removes and a carbocation is formed over here, then the compound form will be and finally when this is attached to alcohol, we get an ester. Which is PDH2Cl. Now let us see what is there in question. Now we are given that C8H7O3Cl is obtained, which upon treatment with methylamine gives a compound C, which is C9H11O3. Now reduction of C with PDH2 yields A, and a compound B, this compound whatever it may be, 1, 2 or 3, when it's treated with sodium NaOI and subsequent treatment is done, a product is formed with dilute acid solution yielding a 3,4-hydroxybenzoic acid. We need to find A. That is, B is undergoing iodoform test or chloroform, or in general haloform test. Therefore A must be, B must be first, second, because only second can go iodoform test. Now finally, as it's given in question that B reacts with methylamine to give a compound C, let us see what is it. When we add methylamine to this compound, we will get basically the Cl and hydrogen will combine and it will form HCl as a side product, and NHCH3 will be attached over here. So this is what our compound B is, as it even matches with our formula, and compound C is this. And as we know, as compound C on reduction with PDH2 yields compound A, so therefore reducing this with palladium and H2 we will get the compound A. So the compound A is NHCH3. As we know that palladium with H2 reduces all aldehydes and carboxylic acid and anything into alcohols. So this is how we need to solve the questions. First of all, the most important point is, before solving any question you should know all the reactions and mechanism which they follow. And the second important point for solving this type of lengthy question is, first see what part of the question you can solve first. Like in this, I have not started with A or not started with C. I was given the information about B. That's why I started with B, because I was given two reactions of B. So I find in the first reaction I plotted the possibilities, and from the second reaction I got the confirmation that only one of them is possible. And by this I just taking that possible compound of our B and doing the corresponding reactions which were given in the question, we get C, and similarly we get C. So the main part in the whole organic chemistry is to focus on mechanism and how, and not just on rote learning. Thank you.